Good afternoon everyone and welcome to today's worked exam answer video. Today I'm having a look at two multiple choice questions on condensation polymers, and I've chosen these two specific multiple choice questions to highlight a couple of things that perhaps are not commonly gone through as a part of the teaching of this topic, and in my experience when I've used these questions with my tutees over the last sort of 2 years, I've found that these are questions that they've been a bit, I didn't know we could do that, or I'm not really sure how to approach this. So that was my thinking here. So let's get straight into them. So with the first question, we're having a look at a diacyl chloride, and they've given us the specific name of this particular diacyl chloride as suberoyl chloride. So you can see we've got the COCl on the right hand end, which is very recognizable as the COCl, but then we also have a COCl on the left hand side, which looks really different because we've got to have the carbon of that functional group next to the CH2s in the middle. Not a lot of students are aware initially that an acyl chloride can be used to make condensation polymers in place of a carboxylic acid. So it's the C double bond O that is the really important component of the carboxylic acid group. The OH part of the COO group comes off and is used in the formation of the second product, which is water. Here, an acyl chloride still has a C double bond O. So this will look something like this. So instead of removing the OH of our carboxylic acid group, we can remove the Cl's of our acyl chloride group, and we still have the C double bond O that we need. We're just going to end up with a different second product in this reaction. We're not going to make water, we're going to make HCl. So in this question, we're being asked to identify from the options a compound that can form a polymer with the suberoyl chloride. So when we're forming condensation polymers, we're looking to either make an ester linkage, so a C double bond O then a C single bond O, or an amide linkage, which if we're thinking about amino acids, we might call a peptide bond, but an amide link is C double bond O adjacent to an NH. Here, we would therefore need to be looking for either an alcohol to give us our polyester, or a diol more specifically, because we're going to need an OH on both ends, just like this diacyl chloride has the COCl group on both ends. So an alcohol diol, if we're trying to make a polyester, or a diamine if we're trying to make a polyamide. And the only option that has two amine groups is A. So what would then happen is you would get the HNH. Each amine group would lose a hydrogen. That hydrogen would react with one of the chlorines coming off of the suberoyl chloride. In the middle, we'd then get C double bond O NH, which is our amide linkage, and on the ends, you would have the continuation bonds to show that we can have many more monomers join on in exactly the same way. So HCl will be your second product, and that will enable us to make a polymer. We can't do that with any of the other options because we've either got another diacyl chloride, we've got a dicarboxylic acid, and that's going to give us more C double bond O's, not the single bond O or the NH that we need. And then C, it does have an NH2 group on one end, but that's actually already an amide, so that's a bit of a weird option that they've put in there. So the answer we'd be looking for here is A. And one way of making condensation polymers is to use two monomers, where we've got one monomer that has the same functional group on either end, and another monomer that then has the other functional group necessary on either end. Leading into my next question, which is thinking about polymers that can be made from compounds that can self-polymerize, might be how they word it. Here they've said which compound can form a polymer without needing another reagent. That means if it's going to be able to form a compound without needing another reagent, we need to have both functional groups in the compound if we're not reacting it with anything else. And amino acids are a great example of this because they have the NH2 group and the CoO group in them, and that's why amino acids can join to themselves, either the exact same amino acid or we can get a chain of different amino acids, and they are condensation polymers, the polypeptides and proteins that are made, and that is an example of a condensation reaction. We don't have any amino acids in our options. What interestingly they've done is they've put in a diol, they've put in a dicarboxylic acid. Them two would react with each other to make a condensation polymer, but they're certainly not going to be able to polymerize with themselves because we just have the OH to give us the single bond O, or we just have the C double bond O here. In D, we have a carboxylic acid on one end and then we've got a random Cl on the other. We can't just take off any Cl, it has to be a Cl of a COCl group, the acyl chloride group. But again, that's not going to help me if I've got a carboxylic acid on the other end. So we're looking for the compound that has both functional groups, which is C, because we've got the OH on this end, which will lose its hydrogen. And we've got the COCl on this end that will lose the Cl, giving us HCl as our second product again. And then the C double bond O and the single bonded oxygen here will then give us our ester linkage as we join many of these compounds together. So that would be our answer for the second question. Hopefully both of those examples make sense. If anything that I've said is unclear, as always, please let me know. But yeah, that's a couple of parts of the condensation polymers topic and associated questions that I just thought it'd be really good to run through. I suspect those of you in year 13 have either just looked at these or will be coming on to them soon, so I thought it was a really good time to do this. Any questions, as I said, please let me know, and thank you so much for watching. Hope you have a wonderful rest of your day.